those numbers down. And we're going to dry run so we can keep track of the values. Right, we're awake. Right, so insertion sort. Visits each number in turn, okay, or each position in the list once. So it just runs through this list once. Well, it doesn't, but that's effectively it does. The pointer, the position that we're examining, we look at each one once. Unlike bubble sort, which like keeps going back through the lists. Okay, it uses a simple premise. It assumes that if we're looking at this position, that everything that we've already been passed is in order. Okay, that's the premise it uses. So we don't have to worry about anything else being in order and say, right, okay, let's just look at the one we're going to look at. Because of that, we don't actually start with the item at position 1. Because you assume that if you've just got one item, that must be on its own in order. So we start at this position. Okay, so set your value for position to 2. And the first thing we do is we take a copy of that value. We call that the key, because generally we're working with unique identifiers for this stuff. So we'll take a copy of that value, because we're going to obliterate it in a second, potentially. Right, what we now do is we look for an insert position. And the insert position is always to the left of where we just started. So the insert position starts at 1. Okay, so in this case we've got insert position there. And we do a test. Okay, and we say, right, is the key value we've got, 23, in the right order compared to the one at the insert position?
Yes.
Yeah, it is. So that's it. We don't need to do any more searching. Okay? And we say, right, fair enough, they're in order. So we'll move to the next position. So we add 1 to position. And we grab hold of the key value there. The key value this time is 12. Remember, if you're going to do a dry run like this, the exam board, like you do in dry runs where you say what line number you're on and all that. But you don't need to. All you need to do is look at the last number you wrote down to see the value of that item. So key is now 12. The insert position is to the left of our current position. So the insert position is going to be 2. And we're going to look back through this list. Okay? So we know that everything to the left of where we're currently looking is in order. And you can see it is. Alright? So right, we say, right, okay, are they in the right order? No. What we do is we shuffle the value that's at the insert position across to the right. That's why we take a copy of 12, because we've now obliterated it. What we do now is we move the insert position back 1. So we go backwards with the insert point. So insert position becomes there. So we're going to look back. We're going to say, okay then, we're still going with this 12. Is it in the right position compared to the current insert position? And it's not. So we need to shift that across, out of the way. Okay. What we then do is we reduce the insert position by 1. We've gone off the end of the list, and that's one of the conditions that tells us to stop. Either they're in the right order and we stop, or we do that. We go off the list. So if we go off the list, what we say is, right, okay then, add 1 to the insert position and put our key value at that position. So if we add 1 to the insert position, we end up sat there and we put our key there. Okay? So it's actually quite weird. You're scanning back, okay, shuffling things out of the way, which is why it's based on a card shuffle, because you do that with your cards. But by removing the card, you're automatically shuffling backwards. Okay? Right. So we've found that position, we move to the next one. So we move pause across to 4. Grab hold of the key that's there. That's the one we're going to try and find the right position for. 14. Now if you look, these numbers to the left of 14 are in order. So that premise of everything we've looked at so far is in order. Okay? Set the insert position. So the insert position is going to go there to 3. And we're going to say, are they in the right order? They're not. Shuffle the 23 across and reduce the insert position. So the insert position becomes 2. And we're just looking back. So what we're doing is just scanning back through the list. It's actually easier to do than it is to actually write the algorithm. Oh, in words. Okay? 23 and 6, not 23, 14 and 16, are they in the right order? No. Shuffle the 16 across.
Put the import point back to 1.
Yeah, and go back with the insert position. So look at up here again. Is it in the right order with 12? Yeah, 14 and 12. Yeah, it is then. Alright, it is. So, we've found the insert position. So what we do is we add 1 to the insert position, and that's where we write the key. It's a really weird algorithm because you do this. The insert position is add 1 to get it. Weirdly. But it's the thing that handles the going off the end of the list, because you add 1 and you're back in the list again. So it handles that. Right, so we've looked at 3 items and we've got the list configured so far. So let's move pause up to the next item and grab that value. It's a 2, so this is going to be a pain in the neck. A lot of shuffling going to go on here.
The insert point goes to 4.
Yep. Yeah, the insert point is just 1 less than where you're looking to start with.
The position in 5 becomes 23. And the import
Yeah.
move back 1.
So we're going to shuffle, aren't we? We can see what's going to happen here. We're going to look. 2 is less than all of those. We can see that. The computer can't. It's doing it instead. So it's going to end up shuffling all the numbers that way. We're going to keep going until we fall off the end. So the insert position is going to go 4, 3, 2, 1, and stop at 0. All these numbers are going to get shifted over. Okay, and our insert position is there. So we stop because we've gone off the list. There are no numbers to check against. So add 1 to the insert position. Okay, which puts it back there. That's where we need to put our key value. Okay. 1 more space to check. You've got to check all of them. You can't say I can't be bothered to do anymore. Generally, computers don't turn around and say they can't be bothered to do anymore. Oh, don't let me open calculator again, like you lot do. Right, so we grab the key value, set the insert position. So the insert position in this case, I'm going to carry my list on here, goes to 5. Pause is 6, and the key is 50. Luckily for us, I must have done something clever to make this happen, because I've run out of space. They're in the right order. If we increase pause again, we go off the end of the list, so we must have stopped. Okay, we've examined every single item. And they're all in order. But it only works because the way it's structured says wherever you're looking, everything else you've already walked past has been sorted. Okay? Right, I'll stop the vid there and then I can upload that separately.
I do it completely